Welcome to Let's Calculate Something. Today we have a practical physics problem. This is a problem I encountered. I was driving along a road and a train was approaching me. And so what I did is I timed, I'm always curious how long trains are, how many cars they have. So I timed the length of the train as I was traveling, estimated the speed of the train. I was traveling about 75 miles an hour. Speed of the train was about 35 miles an hour. And so what I wanted to know was how long the train is. So what I did is I clocked how long it took till I reached the end of the train with my odometer on my truck, and it was 1.3 miles. So based on that information, I wondered if I could calculate how long the train was and how many cars it has. And so what we have to do is take into account the relative speed over this distance here, because since the train is moving one way and we're moving the other, we have to look at relative speeds. And then from that information, and what I looked up about the distance between two train cars, and then how long an average train car is. This was a freight train, how long an average hopper or something is. It's about 60 feet. We can calculate everything we need to know. So what I have to do is take the relative speed. So since we have one speed going this way and one speed going this way, the relative speed, if we put a sign on this one, we'll call this one minus and we call this one plus, since they're going in opposite directions, the relative speed, or the rate, is 75 minus 35 equals 40. Sorry, it's a very sloppy 5. There you go. So it's a 40. So that's the speed we're using. So what we have to do is take and find out how long did this take to happen. How long did it take for me to cover the 1.3 miles to the end of the train? And so we use the rate times time equals distance formula with the relative speed. And that is 40 times time equals 1.3 miles. Now, this is 40 miles per hour, so the time will be in hours. And that time equals 1.3 divided by 40 hours, which equals 0.0325 hours. Sorry, 0.0325 hours. And if we multiply that by 3600, we get seconds. And so we will have, it's about 117 seconds. Okay, so like almost 2 minutes to pass the train, which is about what I experienced. So I'm thinking this is right. And so that we have that value. Now, what we really want to know is how long is the actual train. So if we base that on 35 miles an hour, and we use this formula again, now that we know the time, we just use the time on the actual speed of the train, and we'll have the actual length of the train. Okay, so the actual length of the train is going to be, I'll call it RT times dt, rate times time, equals the distance of the train. So this is the t here. These were relative. These were relative. This is what we did with the r, relative here. So this is, so the rate of the train was 35 times t, which we know is 0.0325. That will give us the distance. And that'll be how long the train actually is. And when we do that, the train is actually 1.138 miles long. Okay, so that answers the first part of the question. And so that is 1.138. We'll write that down over here. So the train is 1.138 miles long. So now what we have to do is figure out how many cars are on a 1.138 mile train. And so to do that, but to kind of come up with a formula for this. And what we know is the number of cars, for every car, we have a gap of 4 feet. And then in the last car, there is no gap. So the formula for that is going to be, if we look at that, it would be 60 times the number of cars plus 4 times the number of cars minus 1, because we don't have 1 at the end, right, will equal 1.138 miles. Okay. Now, we don't really want to calculate the size of the car in miles because it'd be a super small number. What we really want to do is calculate the size of the car in feet, because we already know that's in feet and this is in miles, so it's not going to work out too well. So what we need to do is convert this to feet. And 1.138 miles times 5,280 feet per mile equals, so we have to say how many feet is in 1.138 miles, and that turns out to be 6,006 feet. So we rewrite this equation as 60c plus 4c minus 4 equals 6,006. So we get 64c equals 6,010. We divide that, and c equals 93.4. And since we can't have, or 93.9, I'm sorry about that, 93.9, since we can't have 9/10 of a car, we'll just call it 94. Approximately equal 94. So the answer to the second part is that there were 94 cars. So it's pretty cool that we can actually just clock with our odometer. Don't have to worry about the time or anything. Look up a little bit on Google how long a train is, and bam, we can figure out how long that drag was. They call a long train a drag. How long that drag was, and then how many cars are on the drag as well. And 94 cars seems about reasonable because it was a pretty long train, and it took, you know, almost 2 minutes before I overtook the train in the opposite direction. So thank you for watching. If you learned something from this video, give us a like, give us some comments and feedback, and please subscribe to our channel and click the notification bell. We'll see you in the next video.